Okay, thank you very much for sparing your precious time today. I'm Taka Taguchi from Helical Fusion. I'm so delighted to have this opportunity to introduce our company to you. Here you can see today's agenda about us, business model, our technology, and message to you. Well, let's get started with about us. Humanity evolves with nuclear fusion. This is our vision. We believe we can achieve world peace, energy self-sufficiency, carbon neutral, hydrogen society, and space living by realizing fusion energy. We think this means we can update ourselves by fusion energy. We have professionals in fusion and business. Dr. Miyazawa and I are co-founder and co-CEO of Helical Fusion. And Dr. Miyazawa is the head of R&D, and I'm in charge of business. I'm not expert in fusion technology. I was working for Japanese bank and the governmental bank of Japan and a consulting firm for several years, and co-founded this company, Helical Fusion, with our researchers in the last year. And we have other brilliant experts in fusion technology. And here are our current shareholders. And Mr. Naruke is the former president of Microsoft Japan. And Mr. Fujino is a CEO of Rails Capital Works, which is a prominent asset management company in Japan. And Sony and Plug and Play Japan, which is a strategic investor in Silicon Valley. And other powerful investors have joined us as shareholders. Next, our business model. First of all, we, Helical Fusion, are planning to develop a fusion reactor as a whole system. And we have two business models. Business model A is to provide a design of fusion reactor and consultation on construction, operation, and maintenance. We will receive a design fee and advisory fee, mainly from power generators. And business model B is to provide elemental technologies to fusion startups in Japan and overseas. We will receive a license fee from such fusion startups or laboratories. And our goal is starting the first commercial fusion reactor by 2040, as written in phase 4. And we need to construct some test devices before phase 4. And now we are in phase 0 to phase 1, and we just finished the fundraising for phase 0 R&D 2 months ago. And please let me introduce our technology. The method of using a magnetic field is effective for realizing fusion. And there are two main methods for this, tokamak and helical method. And the helical method we are working on has a bit complicated structure, but is much easier to operate than tokamak. So we think the helical method is suitable for stable power generation. And this figure shows the fusion triple product as a fusion functional plasma in the vertical axis, and the plasma duration time in the horizontal axis. As you can see, high fusion triple products have been demonstrated in tokamak plotted by blue symbols. On the other hand, long plasma duration times have been demonstrated in helical devices plotted by red symbols. And there are two routes toward the commercial fusion reactor. And one is to demonstrate a high fusion triple product first, and then prolong the plasma duration time. That is the tokamak route. The other route is to demonstrate a month or year-long plasma duration time first, and then increase the fusion triple product by increasing the device size and the magnetic field strength. That is the helical route. Since a long plasma duration time over 1 year is inevitable in the commercial fusion reactor, so we push the helical route. In addition to the plasma technology, we will develop innovative technologies in the main elements of fusion reactor, such as diverter, superconducting magnet, and blanket. We are going to develop two kinds of HTS, high temperature superconducting magnet, called stars and Ys. These HTS magnets can work above 20 Kelvin and can be cooled with liquid hydrogen or gas helium. The operating cost is expected to be lower than that in the conventional reactors using low temperature superconducting magnets, because there is no need to prepare a large amount of liquid helium in the HTS fusion reactors. As for the blanket systems, we will develop an advanced liquid blanket, which uses molten salt or liquid metal as a coolant. We are also considering a new idea of first wall protection by using the liquid metal surface flow, as shown in the figure. A low maximum pressure in these liquid blankets ensures the passive safety. A low manufacturing and maintenance cost due to short piping route and few welding points are also the strong points of the liquid blanket. Now, finally, please let me give you some message. Now, we welcome strategic business and financial partners and potential team members with enthusiasm for achieving fusion energy. So I'm so happy to be here today and have opportunity to meet you. We are truly looking forward to realizing fusion energy together with you. And we believe humanity evolves with nuclear fusion. Thank you.